Hello, ZX Prism here again, and I've got something kind of special today. A week or two ago, I had a chance to meet a wonderful person named Jeff, who's been developing a brand new FPGA-based computer based on fully compatible with, but expanding upon the humble ZX Spectrum. Has 512K of RAM, lots of different colors, can be displayed. It has extra sound chip compatibility. There's a raft of things that it does that the old Specky, even the 128K models, doesn't do. So without further ado, I will show my interview with him. The first interview I've ever done. I'll show you the interview that I did with him. But please bear in mind, I shot it with my phone in a noisy meeting room with a whole bunch of retro computer nerds. So it's a bit rowdy, but I think the voice quality is okay. And I think that you'll get the point. So it's about just under 15 minutes, I think. But I'll put some links underneath to his blog and some other bits and pieces. Yeah, enjoy. I'm here with Jeff. Hello. At the Amiga Retro Brisbane meetup in September 2021. And we have this marvelous thing here. This is a homebrew Spectrum machine.
That's correct.
Yes. So let's why don't we just have like a tour? So what's each of these bits doing?
Okay, so on the bottom here, this is a TZX Duino,
Okay.
which is an open source project which anyone can build. It's a virtual tape drive.
Yep.
And it works on the ZX81, the Spectrum, BBC Micro, many 8 bits that you have a tape input.
Yep.
And so that's all that's doing is it's a virtual tape drive.
Okay.
This on top is a Cyclone 4 dev board.
Okay.
Or this side under the perspex.
The one on the far on the back there.
Yeah, all this under the perspex.
All of it under the perspex.
Yep.
Okay.
And then all the rat's nest soldered onto it is all my sort of extra bits of joystick interface, PS2, keyboard, VGA, audio, SD card,
Okay.
and tape.
Okay. So these, what about these? Is this like an LCD display?
Yeah, so this is all parts of the dev board that I'm not using.
Okay.
Parts of it.
Yep.
Parts of it are being used, parts of it are not.
Okay.
So I'm not using the LCD display.
Yep.
I am using the control buttons, but
Okay.
I've remoted them onto the joystick port.
I see. Right. Yep.
I am using the serial port, but that is connected to the tape interface and
Yep.
is acting as a level converter stroke buffer
Yep.
between the horrendous or potentially horrendous voltages I might try and feed in
Okay.
from a cassette port.
Yep.
So it protects the FPGA.
Okay.
And it runs perfectly fast enough for Spectrum tape.
Sure. Yeah.
So, 1200 bow normally, and
Yeah.
faster with hyperloads.
Pretty pedestrian.
Yeah.
Yep. Awesome.
That's probably about it. Anyway.
That's yep. So this is like a div MMC, I think you said.
So yeah, that's the SD card part of it.
Yep.
The main part of the hardware is modelled within the FPGA.
Yep.
So all the ROM paging and RAM paging, NMI handling and
Yep.
auto paging
Yep.
is handled within the FPGA.
Okay.
Likewise, all the glue logic for the Spectrum itself is handled within the FPGA. All
Sure.
the video creation
Yep.
out to the DAC is
Yep.
handled on FPGA.
Yep.
Virtual CPU,
Yep.
virtual AY sound chip, virtual SAA 1099
Okay.
sound chip.
So it can emulate a 128K Spectrum.
It's actually 512K.
Oh wow. Okay.
So yes, it can do 1 to 8K.
Yeah.
But it also uses the paging mechanism from one of the Russian Spectrum
Yep.
clones
Okay.
to do 512K.
Ooh, nice. Yep.
That's with a couple of caveats, because there's only 512K In fact, it's 256K
Yep.
SRAM on the board, but it's 16-bit, so I've cut it in half because
Yep.
the Spectrum's 8-bit.
Makes sense. Yep.
So it has 512K, but the last 128K is shared with the Div MMC because it needs some memory.
Yep.
And then the 128K before that, going backwards in the memory pages,
Yep.
is also mirrored with the memory paging of the Timex, also sort of models.
Sure.
I don't want to use the word emulation because I don't believe that FPGA is emulation.
Yeah.
I believe it's modeling.
Yes.
It's contentious. I don't want to have any arguments with anybody.
Yeah. No. I do tend to agree. But it's not kind of absolute though. Like you could you could conceivably port like Box or QEMU or something, rewrite it as VHDL code, and then you haven't modeled an x86 CPU.
Correct.
Yeah.
I mean, I'm using T80.
Yes.
So it is a model Z80 that works with the ALU and everything.
Yep. So they're very much
so it's very, very, very similar.
Yep.
I did have one that was even closer modeled on the Z80, and I can't remember what that's called, and I'm really sorry to the person who sent me that. Because the guy that wrote it and I talked about it for quite some time. I just couldn't get it to work with the rest of the stuff I'd already modelled.
Right.
So it wasn't just a drop-in replacement for the T80, unfortunately.
Right.
But yeah, like the glue logic is very much like most. I don't go down to emulate modelling a 7404.
Yep.
But I will use all gates, AND gates, and so on the thing as I need.
For sure.
Rather than just, in some cases I've got what looks like coding.
Yep.
And that does save writing a whole heap of symbols all over the place.
Of course, yeah.
But yeah,
very cool.
It does the stuff.
Yeah.
I'm currently showing off on screen. This is basically the double height and double width resolution.
Okay.
I'm only currently using two of the bit planes. So the Spectrum 128 had two 16K pages of memory that it used for screen.
Okay.
So there was page 5, which was the main screen stored in that, and page 7 was the shadow screen, and you could flick a bit on a hardware register and it would swap between the two.
Right.
So you could do kind of double buffering.
Okay.
Or you could just use it as a shadow screen and just swap between them for different tasks. Whatever.
Sure.
So if you consider this to be page 5 and this to be page 7, you would be correct in the way you were interpreting what you see.
Okay.
But on Prism, the second 8K, so if you split those into 8K, the second 8K on a normal Spectrum would, in BASIC at least, would contain all the system variables.
Okay.
And if you started writing a screen to that, you'd crash the whole thing.
Right.
Unless you were just doing stuff in pure machine code. I wanted to be able to use it from BASIC.
Okay.
So what I've got is what I call a VRAM aperture.
Okay.
Which at boot is set to 6K.
Right.
And that means that VRAM is only in the screen part of that first 16K of memory. That first 16K of RAM.
Right.
Sorry, ROM comes first.
Yeah.
16K ROM and 16K RAM.
Yep.
So only the first 6K is VRAM.
Okay.
And you can swap which one of these is written to when you when you write to that location.
Okay.
Additionally, you can also make it write to multiple ones, which is what we're demonstrating here. So if you look at this, if I pull up bubble bobble.
Yep.
It works. We're demoing, so of course it won't.
Yeah.
There we go. It's something. Alright, so it's a cracked version of Bubble Bobble, so
Yep.
no idea what's going to happen next. But you can see it's it's repeated on both.
Yeah.
The reason it's two different sets of colours is that Prism has a 256 colour palette.
Yep.
Spectrums typically have 16 colours on screen maximum.
Yep.
15 really, because both blacks are the same.
Yes.
But because it's paletted and you can redefine them,
Yep.
16 colours, 16 colours.
Okay.
You can set an offset into that 256 colour palette.
Yeah.
So this is set as an offset. This one's just a grayscale palette defined. That's not going to do anything interesting, unfortunately.
So Prism.
Here we go.
Prism is the name of what you built.
Yeah,
Okay.
it's yeah. So there's various Spectrum clones. There's the Spectrum Next, which was announced after I started working on this, and it does a few things that this does, and it does a bunch of other stuff.
Sure.
You know, I am not competing with that at all. This is a completely different type of machine for a completely different type of person.
Yep.
But you know, some people like to try and work on a rivalry there. I don't have a rivalry. There's the Russian clones. There's Chrome. There's Harlequin, which I think is a normal Spectrum that's just made out of 7/4 components from memory, or modern components anyway. There's a whole heap of them.
Okay.
Prism is mine.
Is yours. Okay, great. Cool. So we have grayscale, and that's because the color map for that plane hasn't been initialized or given.
If it hadn't been initialized, it'd all be white or it'd all be black.
Oh, I
I
see.
can't remember what I defaulted to now. I think it's all black.
Okay.
Basically, the 256 color palette. My first 15 colors are as best possible match to the Spectrum colors.
Of course, yeah.
The next lot are a variation on that.
Okay.
I can't remember if it's dimmer or brighter at the moment off the top of my head.
Sure.
And the ones after that I think are grayscale.
Okay.
And then there's a green scale, there's a blue scale and so on.
Okay, I
Simply
see.
because I wanted some arbitrary but useful-ish groups of 16 so I could do demos like this.
Yes,
I just happened to choose grayscale.
Okay, I see. Very cool. That's really awesome. And you brought a tape player. Did you manage to get this to work? I know you.
Yep, yeah, I got the tape player to work. I didn't get the virtual tape player to work.
Oh, okay.
Basically, last time I used the virtual tape player, I was trying to record from it onto normal cassette.
Oh, yeah.
So I had to turn the volume right down to try and cut down the noise.
Yep.
Didn't work. I forgot to turn it back up again before I came out, and it's all screwed together, and I don't want to take it.
Fair.
Basically, there's a little amp in there. It just needs turning up.
Yeah.
Next time I bring it, I'll demonstrate the virtual tape drive.
Fantastic.
But it's an open source project. There's plenty of videos of TZX Duino and Kaz Duino, which is that project.
Yes.
There's plenty of videos of that where you can see them working and you can make your own very easily.
Yeah. I've seen a few. We'll cover it before. Yeah. Awesome. And so everything that you've done here it's like blogged and like documented, or
I have a blog, which is zxprism.blogspot.com.au.
Okay.
It is out of date.
Yep.
But you can follow the development history up to a point.
Yep.
And I think that point is probably around the time my son was born, 7 years or so ago. And then there's a couple of little updates.
Yep, sure. Oh, that's cool. And like, do you think you'll reach a point where it's finished?
I'm almost considering it finished now. There's a couple of things I want to tinker with.
Yep.
Just so I can feel comfortable. I was going to add a mouse.
Yep.
I was going to add multiple joypad button support to the joystick.
Yep.
a couple of bits and bobs like that, so nothing major.
Yep.
To get the mouse, I need to find bi-directional ports for a new PS2 interface.
Okay.
And at the moment, that would mean disconnecting the main board from the daughter board and re-implementing the bits on the daughter board that I'm using
Right. Yep.
on my own hardware.
Okay.
That's what's held me up because I don't have the time to do it.
Sure. Yeah.
Being a dad.
Understandable. Yeah. Well, that's really, really cool. So thank you. Thanks for your time.
Thank you.